There we go. We're on day 12. All right. So that means we're about a week away from the exam and people have questions. Yay. Okay. So let's answer those questions first. Now, remember, before I even get into the questions, we're going to work on two worksheets now. I'll do more of the 6-2 with you guys and not too much of the chapter 6 review, but I will help you with the gambling one because I know the gambling one is always the one that people are always like, what's going on? Um, Remember, you want to come to class next Monday or Tuesday or both days. Sometimes students come twice for the sample midterm, and with as much done as you can do, right, on that sample midterm. Practice taking it like an exam. Practice it. Steve said it's like a diagnostic, right? Just get your yellow packet and your note sheet and that sample midterm and see what you can do. See what you can do with Desmos and StatCrunch. Whatever you can't do, that's the things that you need to start putting on your note sheet. And you can put anything on your note sheet you like, examples, definitions, all sorts of stuff. It's one sheet of paper, 8.5 by 11, normal sheet of paper. The one thing you're not allowed to do is just shrink your course pack down into little, I don't know, postage stamps on your paper and just have that. That misses the whole point of you studying, right? So don't do that. And it's forbidden, first of all, but second of all, I did have a couple students do it before I forbid it, and they did not do well because you're missing. You got to study, right? You got to practice. So practice taking the exam, practice getting your setup, right? Try to do the sample midterm with the camera and everything set up. See if you can get it set up the way you want. Don't wait until next week to figure out how to do your camera. Because if you need to buy a webcam or something, you need to do it this weekend. You don't want to wait until the day of the exam to do it.
It also came up in another section, the idea of if you're going to be taking the exam at a different place, like if you're planning on taking it on a different computer, make sure that if you're doing the Zoom thing, make sure that you're logged in and you can get access to StatCrunch and there's no firewalls or something like that. We had some folks take it from work and they ran into a problem with a firewall that wouldn't let them get to StatCrunch.
Yes, good point. We had a couple like they were nurses in like U of M healthcare system, and so they wanted to take it at their quiet office, and also it was just it fit the time for like 6 to 8 p.m. they could be there. But the problem was they couldn't get in because they couldn't get into StatCrunch. So practice, right? Whatever device you're going to use, then get used to it. If you're going to go to the testing lab, oh, this is no problem. Figure out how you're going to drive to campus. And figure out how you're going to get there. Oh, and somebody said they don't have a student ID. You don't need a student ID. You need a driver's license. You need a photo ID. Um, that we will have to do. There might be a Google sheet, but it won't be a turn in thing. So if we have one of those tables, I usually have the table pre-built in Google Sheets for you, but you won't be a requirement to turn in the Google Sheet. Does that make sense? That's a good question. Good question. And you can use your own laptop in the lab. Yes, definitely you can. Right. But you can also use their computers if you don't like some people have a PC at home, like a desktop. They don't have a laptop. If that's the case and you're going into campus, they have Chromebooks and or actually you would be on one of their real computers. Then you'd have to have your login and password for StatCrunch so that you can get in. Okay, so all right. If we do not, oh, if we do not use the appropriate symbol and instead use the regular equal sign, would that mark us points down for that? I think it depends on what question you're talking about. I think what you're talking about is chapter 6 problems, in which case, if you don't do the correct symbol, you'll actually have the answer wrong. We'll see that a little bit today with the oh, with like more than versus more than or equal to, like they're not the same. So if they have the extra bar in them, they're actually different answers than if they don't. So it'll depend if that's what you're talking about. I'm not fully sure, but I think that's what you're talking about. In which case, yeah, it would matter because they're different. Right. So, but you have this table. This is in your yellow packet. So you can use this table to know which symbol to use because it kind of connects up to the words. Oh, another good question for Zoom. If you're taking your test on Zoom, do you end the Zoom so then you go scan? The answer is yes and no. It depends. Some students they have like a webcam instead of using their phone. So they'll actually just pull their phone out and be like, they'll write us an email because we send them an email and they'll write us an email like, I'm ready to scan. And then I see them starting to scan. Like it's very obvious what you're doing when you're scanning. You know, you're not looking for answers. You are taking your horizontal pictures with your phone. So it becomes very obvious what you're doing, and that's fine. So, but not all students can do that. They're using their phone for the Zoom, and so they can't always. So in that case, That's one of the reasons you let us know you're done. You wait for us to say, yep, okay, you're done. And then we write your time down, and then you have 5 minutes to go upload it. And if you have issues with your internet, what you do generally is you write us. You say like, I'm having issues, but I'm still on it, or I'm working, and you get it in there in 6 minutes or whatever. But you're writing us back and forth. Sometimes students send us an email with it first because they know they can do that faster, and then they're uploading because uploading takes time sometimes. And then somebody's complaining about 6.2. Actually, I will hopefully I'm going to get you on my side. I think 6.2 is one of the easiest sections you've had in a while. I think you don't realize it yet. I think I'll get you on board once I go you through it. It's easier than 5.3, I'll tell you that. 5.3 has got those multiplication ones. Those are the things. All right, can we cover for it? Yeah, I'll help you with the raffle one. It's the Baccarat one. Hold on, I gotta move things. What happens if you don't pass the midterm? Well, it depends, right? Your grade is a weighted mean, right? So your grade is made up of all the things. So you have the final, first of all. The midterm is worth 30% of your grade. Sorry, I'm just pulling up the syllabus so you guys can see here. Okay, so your grade is here. So 30% of your grade is the midterm, right? So a lot of your grade is the other stuff, the notes, the classwork, the projects, right? But 30% of it's the midterm and 30% is the final. So for one thing, you know what you have to do maybe a little bit better for the final. For another thing, it depends on what you mean by not passing. If you get like something, remember passing grade is 70, right? You want to get a minimum of 70 overall for the course, right? So if your midterm grade is at like a 65, well, it's not passing, but it's close, right? And so the rest of your grades can maybe pull you up, right? But if you get like a 20, that's a different conversation, right? Then you've really gotten low grade. It would take a lot to try to get it up to passing overall, right? So it would depend on your situation. It would depend on what you've been doing. It would depend on other things, right? How well can you do on the final? Did you learn a lot from this, et cetera. The other thing to think about is the money for the class is spent, right? No matter what, it's gone. So you want to get as much out of it as you possibly can and do as much as you can, because if you don't pass the class and are not successful, you're probably going to have to take it again to get a successful grade. And it might take you 2 times to learn all the material, and since the money is spent, you might as well get as much out of it as you possibly can. Does that make sense? Also, there's a way as a student, I can't do this as an instructor, but you guys as students, you can play with your grades. Do you know what I'm talking about? Like in the grade book, you can go in and like put in different grades for yourself and like give yourself like a 40 on the midterm and a 50 on the final and see what you get overall in the class. Or give yourself do you know what I'm talking about? Everybody know what it's talking? If you go in Canvas and go to your grade book, you can mess around with things. Like try different things. Try like give yourself like a 65 on both the tests and then see where you're at. See what it's doing. Is that remember? However, Steve and I are a little bit behind on grading. Not tons behind, but we're a little bit behind because we're writing exams. We just don't like there's only two of us, and we also have other classes. We just can't produce fast enough. So I graded 5.2 today. I got 5.2 all caught up, and I got some people turning in some late stuff, so I kind of got that caught up. Steve promised me he's going to be grading a discussion board tonight, so that's going to happen. Like we're getting there, but the worksheets just take a while to grade, and I have to write exams. So I'm working on it. So but nevertheless, you probably have a good sense of where you're at, so you can kind of play around with your grade with that. Hopefully that helps. And then, oops, what chapters will be in the midterm? Oh, good question. So it said in the instructions, I'm just gonna go back to these. Remember on the midterm day 14, there's a whole proctoring sheet, and we sent this out to you guys too because it was in that survey you guys took for where you're taking your test. And there's like all sorts of info. Make sure you read over this. Like make sure you look at it's a paper pencil exam. It's not a typed thing. Nobody's typing. Nobody's using their tablets. They're writing on paper, right? Either you print it or you work on blank paper. Do not cobblestone it. Like like it looks like a cobblestone path. Don't do that. So it's a paper pencil test. And then what chapters will be on it right here. The exam covers chapters 1 through 6, but for chapter 1, It's really only 1, 1, and 1, 2. Those are the only sections we've learned. Your discrete, your continuous, your parameter, statistic, all that jazz. Explanatory variable, response variable. The rest of chapter 1 we don't do until after the midterm. Okay. And then I think I got all the questions. Actually, real quick, I didn't even tell the morning class this, right? That's true. A good point, Cami. Yes, there is partial credit. So, not for a problem that's worth 1 point, maybe not, but for things that are worth more than 1 point, yes, you can get credit for setting it up right, writing the right formula, having the right script, but you missed part of it, but you got part of it, right? Things like that. Absolutely, you can get partial credit, right? And then the the midterm. So just keep in mind, once you come to the midterm, either in person or in Zoom, you don't come to the Zooms for the rest of the time. So I'll keep sending the texts out being like, there's an exam right now. But if you've already taken the test or you've already done it in the testing lab, you're out. Don't worry about it. Oh, and somebody in the afternoon class was like, but it says there's a due date time. Should I be worried if I do it late? No, no, no. The due date time just helps us because then we know what you guys don't see is in the grade book, it makes things different colors if they're like on time versus late versus and we can actually like see when people were doing the morning versus when people were doing the evening. It just helps us. So don't worry about it. You're not marked down if you do it Thursday. It's fine. It says the due date is like Wednesday night, but technically it's like Thursday. Don't stress. No problem, right? And then also spring break. So after you're done with the test, you're done for a while because we don't have class for the whole next week. You do have a lot of notes to watch, but everybody look, this is your job over spring break. But two things. Notice that some of those are 2 points. That means there's 2 pages. One of them is 1 point. It's 1 page. It's one video. That's all there is. These sections are the easiest sections in the whole course. So, and we're going to do all of them together. There's a whole bunch of like definitions and 7.1 and 7.3. 7.3 is no problem. 7.3 is literally like the problems in that page. The worksheet takes us about 30 seconds to do. So it's easy sections, but you're going to watch those videos sometime over the week and a half that you don't have class before you come back after spring break. Got it? So don't freak out about it. That it looks more intimidating than it is. It's easy stuff, right? Those I put all the easy stuff after spring break, so that way we could have a nice easy time with it, and it wouldn't be too terrible. So good. Hopefully that's good. I think I've answered everything now. Is there any question I haven't answered? No, I think I'm good. All right. If you have a question, then by all means ask it. All right. One more thing. Sample midterm. I think I said it already, but I'm going to say it again. Don't forget, I did say it, but I'll say it again. Come to class next week with as much done as you can. And some people do come to like morning and night or afternoon and night. Like they come twice because they really want to make sure they're getting it. That is fine. All right, so let's go to 6.2, shall we? I'm gonna get whoever it was that didn't like 6.2. I'm gonna see if I can get you on side. Now, the first thing about 6.2 is it's all here. Like everything you need is here. Like there's nothing. I mean, I guess you could maybe write something on your note sheet that isn't on this yellow packet page, but it's all here. Oh, you take the exam on Wednesday and Thursday. Monday, Tuesday is the sample midterm time. Wednesday, Thursday is the exam time. And that's a good question. Just a little review. Sorry, we'll come back. The exams are here. Let me go back. Wednesday, 8:30 a.m. to 11:30 a.m. It's like class time, but starting early, right? Depending on how soon I get up here and get going. And then 5:30 to 8:30 p.m. Thursday, we're thinking like 8:30 to 3 on Zoom. And then on the testing lab side, it's 9 a.m. to 8 p.m. They're just open. So you just go in and take it from 9 a.m. to 8 p.m. Of course, everybody knows that if you show up right at the beginning, right at 8:30 or right at 9, it takes a little time to process everybody and get people like because we got to write emails to each person and do that. So it takes a second. So oh, that's okay, Julia. So I think I got it. Oh yeah, that's true. That'll be true, Seth. Yeah, coming to the test. But I've had students do it and they're successful. Students do it all the time, coming after their shifts at work. It happens. All right. Okay. Probability. So the binomial probability distribution is nice because it has rules. And the rules are that it's got to be a fixed number of trials, it's got to be independent, there's got to be two options, success and failure, right? And that's it. And the probability of success is the same. So if we look at this first setup, we have this lovely wheel here, right? So we have this wheel and you're going to spin it. And so I've made three different scenarios and all of them are not binomial. And your job is to figure out, like, in what way is this violating the binomial rules? So the first one, you're trying to land on green. You let X represent the number of spins it takes until you get to that green one. So I'm gonna label these. If this is A, this is B, and this is C, which one is the one that's broken? Yeah, because you're gonna keep going. See, binomial is like you have to set it up and be like, I'm gonna spin it 5 times. That's it. That's binomial, right? By not setting the number of times you spin until you get a green, it's that one. Making sense to everybody? Good. You got to set it ahead of time. You got to say, like, I'm going to do this 6 times. And if you don't do that, not binomial. Period. All right. Letter B. You're going to spin the wheel. See, you're going to spin the wheel 4 times. Okay. I got my fixed number. I got you. But you're going to let X represent the color that you land on. Which one's that? Yeah, it's B. Uh-huh. Because it doesn't, what's success? Like, you haven't defined what your success is, right? You're just saying color. So it could be green, red, blue. There's 3 colors. Now, why didn't it do that up here? Because it says right here, you want to be on a green. So green is success. Everything else is failure, right? So green, success, failure. Down here, it didn't say what success was, right? There's no success. So it's not that, right? Here, I'll just write it. There's no set success, right? What are you looking for? Okay. C, suppose there's a secret mechanism that determines what the spinner lands on, and it's run by a fair employee hiding behind a shrub, who will then determine who wins and loses. You're going to spin the wheel 3 times. You're going to let X represent spinning green. So, yeah, it's totally C. But check it out. You're going 3 times. That's your trials. Green is your success. So these two are covered, right? 3 times gets you this, green gets you this. But if it's rigged, then it's not independent, right? Independent is like the first spin doesn't affect the second spin, right? But if somebody behind the shrubbery is actually choosing who wins and loses based on, I don't know, what they look like or whatever, then that's not independent. That's totally dependent. Is that making sense? Everybody's good? Questions? Good? Okay. Now, as for the probabilities, this is why I say 6-2 is easier, guys. See, in chapter 5, when you're doing probabilities, you got to do it all your own self, right? You got to sit there and you got to write out the fractions and square them. Remember that, right? But the thing about binomials is that StatCrunch does them for you, right? So all you have to do is go to StatCrunch, choose Stat Calculator's Binomial, stick the numbers in, and away you go. Right? So, and as a matter of fact, I will reiterate, not only is that nice, but we're going to require it. There are by hand formulas, and if you use them, you get no points because we know that you went to the internet, which is not allowed, right? That is cheating, right? You have to go and do the things we are doing. So you open StatCrunch, you go to Stat Calculators Binomial. All you have to do is put your N and your P in. Like N is like 215, P is point, oh, is that 84? It's 84. 84. And then you just start playing around with the different things. You'd go like, okay, do they want it to be equal to? Do they want it to be a less than? Do they want it to be a greater than? That's a greater than. What do they want? And you just change it and change your number and say compute, and you're going to have it done. Right? Yeah, that's the formula. Steve put it in the chat. So when students use that, I know they have no idea what they're doing. No clue. Like, don't do that. Right? So I'm not teaching it to you for a reason. That's involving something called combinatorics, which we're not getting into. That involves section 5.7, which we're not doing. So knock it off, right? Use StatCrunch. So use StatCrunch to do this, right? Do. So I'm just going to say, oh, now notice, oh, one other thing to notice. In these calculators, and this is not going to go away. This is going to stay in chapter 7 after the midterm. There's two options. There's a standard, which does kind of a left-right thing, or a single number, kind of a single direction. So actually, let me put a number in here. It doesn't matter. Here, I'll just pick this one. Okay, so I can point to the right. All right, everybody see how this symbol right here points to the right? That's a greater than, right? It points the direction that it's going. Right? So greater than is that one. Less than is the other one. Now you can look it up in the sheet, right? It'll show you, but students always get confused about those at first, right? This is a less than. It's pointing to the left, right? That's less than, that's greater than, right? And again, they're on the sheet, so you don't have to memorize them or anything, but you kind of will because you'll get used to them. So that's the standard. Standard is like one of the directions. Then there's also the between. Yeah, that's true. Greater is right, right? And less than is left, right? So less is to the left, right? Greater is to the right. All right, so then there's the between. So if you click on the between, then it gives you two numbers. And then you can pop them in there and say compute, and it'll give it to you. Okay, so I'm gonna let you guys do that one with your group, because that's not hard for somebody in your group. Oop, that's my email. Not hard for somebody in your group to put in, right? Yeah, its mouth eats the bigger thing. That's right. It's like Pac-Man. Yeah. So, but it gets a little more complicated just in that you've got to read it in a particular way. So, let me do this. So, stat calculators binomial. There you go. Use stat calculators binomial. You'll be fine. This one you can spot. It's got two numbers on it. That one's got to be a between one. So make sure for that one you click the between. The other ones are all standard. They're all like one direction or the other direction. But the probabilities, this little bit right here will not take you guys long, because you just type, and you're done. Right? It's not having to do it by hand like you did in chapter 5. That's what I was trying to tell you. So this is not as bad as you think it is, right? At least the probabilities aren't. I can't speak to the other parts of it. All right, everybody got it? All right, so now let's talk about this. Okay, so this is probably where you're struggling a little bit. So trying to get like how this works. So the CDC has found that 40.3% of US adults are obese. You're going to randomly select 360 adults, US adults. We can presume this research qualifies as a binomial experiment. Okay, so they're telling us it's binomial. So our mission is to kind of fill out all the parts. So if it's binomial, what's N? What's our fixed number of trials? 360 right here, right? So 360. Beautiful. Okay, now what's P? What's the probability of success? Right. Okay, so this is P right here, but we don't write it that way. We write it as a decimal. Make a note, decimal, because that's the way StatCrunch is going to need it anyway. And that's also how we need to find Q. P and Q. P is the probability of success. Q is the probability of failure. So if P is 0.403, how do you find Q? Right, Francis. It's right in the sheet. Q is 1 minus P, right? It's right there. They got to add up to 1 because you only have those two options. It's binomial, right? Success, failure. That's it. So you go, okay, well, this is 1 minus P, which is 1 minus, that's why you make it a decimal. So this works. 1 minus 0.403, which is 0.597. I'm just going to circle those. So we got them. There's our answers. Okay. Now, for success, here's my challenge to you. Don't write too much. It should be a word or two. maybe a few words. This one should be one word, and that's it. That's right. Obese. That's it. That's all you do. Don't get into like US adults and this year the CDC. Don't knock it off, right? It's just what are you looking for? Success is obesity. That's what you're looking for, right? And therefore failure, now wait for it. Failure would be not obese. Ta-da! Because once you've determined what you're looking for, in this case obesity, then you automatically know what it's not, right? So not obesity. Ta-da! See, easy peasy, right? Am I converting anybody yet? Okay, so then what about X? X is a little strange. There's kind of a script for X. It's right here in the yellow packet, right? So yeah, well, but it's whatever you're, good point. It's whatever you're looking for. It's not a good or bad thing. It's just what are you searching for? This percentage goes with obesity. So this percentage, because that's success, then that's success. They go together. It's not always a positive thing. It just is whatever it is, right? Sometimes, I mean, I'm trying to think of some of the examples I've done. I've done like death, disease, like because actually disease is a really common one in healthcare, right? You have a percentage of the population that has HIV. So HIV is what you're looking for. That's success, right? Because that's what you're trying to find, right? So yeah, so that's right, Haley. So it's the number, let's read, it's the number of successes, but we just defined success as obesity. So it's the number of obese adults in an, well, trials is the adults, right? So in 360, because we already said it was 360, right? So I like the way Haley wrote that. So it's the number of obese US adults out of 360. Boom. Right? It's a script. So this one, I guess let me make a little note of that one. That one's a little strange. It's a script on page, well, everything for this entire thing is on page 256. I'm just going to write page 256 over here and put a little star on it because all of the answers come out of page 256. It's your yellow packet page. So, but that one's a script on that page. That's right. Landing on whatever you're looking for, that's success, right? Whatever that is. In this case, obese, right? Exactly, Seth. That's a good way to write it. Yeah, the guy that invented this was Bernoulli. Was he Swiss or French? Swiss. He was a French-speaking Swiss guy, as I recall, or was maybe German. Anyway, so he was just writing in Latin or whatever he was writing in. So he's like, success, la, la, la. Imagine him with a French accent, probably drinking some kind of wine or something as he did it. That's who invented this stuff. All right. Now, mu and sigma, we know those symbols. Mu is the, ooh, let's see if we know. The mean, that's right. And this one is the standard deviation, and they're on the sheet. There's little formulas for them, right? You don't even have to do like StatCrunch for these or anything. They're right here. The mean is here, the standard deviation's here. Everything is on this sheet. Everything you need. So, okay, let me write this formula. So this is the mean. This is n times p, which in our case would be what was it? 360 times 0.403. I'm just going to write that. 360 times 0.403. So that's the mean. So everybody grab your Desmos or whatever and find that. I'm going to start writing this one. Standard deviation is the square root of n times p times q, which is the square root of 360 times 0.403 times 0.597. Now, if you're wondering why didn't you give us space to work, I wasn't really expecting, I guess, people to show work for this one, but you can. That's I think that's a classic example of what Cami was writing earlier in the chat. If you write the work, then if you get this number wrong, we can give you some points because we knew you knew what you were doing and you must have typed something wrong in Desmos, right? Right. If you don't write the work and you just write a wrong answer, we have no idea how you got that, so we can't give you any partial credit. All right. Oh, you guys are getting it. Sorry. 145.08. Is that good? And then the standard deviation, I know we've done this before, but I'm just going to go back in here real quick into Desmos. So in Desmos, the standard deviation is the little checkmarky guy right there in the keypad. Me personally, I don't use the check mark. I actually just type it. Square root. SQ for square, RT. Once you type that, SQRT, it just, but if you want to use the keypad, fine. And then you start typing your numbers. So it's 360 times 0.403 times 0.597. And you get 9.3. What did I want? 9.31? It's two decimal places. So 9.31. Okay. Do-do-do. Maybe I'll change those in future so they each have a line so we can show the work. I'll do it later. Not doing it now. So questions on any of those? Troubles or anything? Don't forget, S and F and X are words. NPQ are numbers, and so is the mean and the standard deviation. Those are numbers. Right? This one and this one. Right? And X is actually a little bit more. It's a script. It's got a bunch of words. Right? Okay, now interpreting the mean and standard deviation. This is essentially the give or take script, but we have to add in this extra bit in the front, right? Because when you're talking about a binomial, you have to talk about like how many people you were talking about, right? So we expect there to be, so out of N, which was 360, out of 360 random adults, we expect there to be this many obese people, give or take this many. Everybody see how this is going to work, right? So out of 360 US adults, oh, random US adults, sorry. I should have probably thrown that in there. It's implied, but random US adults, we expect 145.08 of them are, you know what? I'm just going to say adults. How about this? Obese adults, give or take. There's a few ways you could write this, but give or take 9.31 obese adults. Or earlier today, I kind of wrote of them. So 145 of them to be obese, give or take, you know, like see, you could write the English in a few different ways, right? But you're basically trying to get across the idea that it's 360 people. You're expecting this many to be obese, give or take this many, right? You got to put the obesity in there and you got to say the mean and the give or take, right? So it's got some parts to it. This is the new part, right? This is the new, like we didn't have this before. All the rest of this you guys have been doing for weeks, right? The whole give or take thing. We've been doing that a while. But this, the whole, you have to say out of, I mean, if you think about it, if that was missing, just think about this. This would be absurd. We expect 145 obese adults. Where, like in a gym? Like what are you talking about? Like out of how many? Like what you doing, right? So you got to have that piece in there, otherwise it just doesn't make any sense, right? We expect 145 obese adults like at a hockey game. Like I don't know what you're doing. Like I mean more or less, who knows? Like so you gotta talk about like what percentage we're talking about here, right? So that's why you got to have that piece in there, right? Which we haven't had before this, right? That piece wasn't required for other sections, but in this section you got to have it, otherwise it doesn't make a lot of sense. So it's essentially your give or take script that you've always had with this extra little piece added in. And sometimes students add that in the end. We expect 145 obese adults out of 360, give or take. Like people can kind of put it where they want, but you just got to have it in there somewhere. Good there with the script. And everybody saw that the script is right here on your paper. Everything you need is on this page. I'm telling you. All right, next. Well, we've done these before too. Oh, good. I see lots of thumbs. Good. So this is just like what does this mean in English? Like this P and that parentheses and then this X, like what the heck is going on here? That's math talk. Like that's math. What does it mean in English? Like what are we talking about? So the P stands for Probability. Yeah. So the probability, probability. I was supposed to spell probability. Probability of, right? The parentheses is of or that, right? Probability that or the probability of something like that. X, well, we already said what X was. It's up here. The number of obese adults, right? So the number of obese adults out of 360, right? So that's what we're talking about here. This X is the number of obese adults, right? Is here, probability of the number of obese adults out of 360 is, what is that symbol right there? I don't like the word of in this case. I'm actually going to say that. The English isn't quite working for me. I'm just going to make it that. But it's that or of, right? Less, well, careful. It's less than or equal to. See that extra little bar in there? That's a less than or equal to, right? So you gotta watch out. So less than doesn't have the bar, less than or equal to does. And in this section, it's gonna matter, right? Actually, all of chapter 5 and 6, it matters, right? So that's why those are together on the midterm. The probability of less number of obese adults is less than or equal to 360. Oh, and there's a faster way to write this. Somebody in the morning class noticed. Can't I just say at most 360 or at most 160? Oh, 160, not 360. Geez, Louise. Hold on. That's a 160. There you go. 160. Right. So now it doesn't look like it's one number. Hold on. There we go. Okay. So the other way to say this out of 160 is at most 160. That's a faster way to write it. You don't have to write it both ways. I'm just putting it out there. Like both of those are options, right? At most means less than or equal to. You could say less than or equal to. You could say at most. You could say 160 or less. You could English. It is hopefully one of the languages you speak, and therefore you can play around with it. But you have to get something along those lines. I'm just gonna put or because I don't want you guys to think. You don't have to write both of them. They're just. How are we doing there? Everybody okay? We're good. Okay. Now the probabilities. And the thing that's nice about this section is the probabilities are not bad. They really aren't, because you can make StatCrunch do it all, which you can't do in chapter 5. In chapter 5, you're stuck doing it your own self, right? But in this section, we can make StatCrunch do it with stat calculators binomial. Please and thank you, computer. Please make this work nice for me. Okay, so let's go to StatCrunch. And we're going to do a more than. Before I even go, everybody see these words, more than? See that? You grab your table and you look for more than. More than is right here. That's that symbol right there, right? It's a greater than, right? Not with the extra bar on it. It doesn't have the extra bar. So it's a more than. So you're going to go, okay, I got you. StatCrunch. I'm going to close the old one just so you guys can see how I do it. Stat calculators binomial. Boom. I put in my n, which was the first thing we wrote on this page. It's 360. I put in my p, which is 0.403. I'm going to change this sign right here to a greater than, and I'm going to type in 150, right? It's 150? No, 120. 120. And I hit enter. Ta-da! 'Tis done. No formulas, no fuss, no muss. Notice it's pointing to the right. It's shaded red. The red is to the right, right? So to show your work, you write that line. Well, hold on. Does everybody see that there's a line right here? See it? P parentheses x greater than 120 equals. See that? Write it, right? It really helps. And also it helps us when we're grading to know what you did so we can maybe give you partial credit potentially, right? So you go P parentheses x greater 120 is about 0.99. Well, I don't remember what it was. 9962. 9962. 9962. Ta-da! I didn't have to think about like multiplication rules or addition or adding or any of that stuff. It just does it. It takes care of it for me. All right. Next one. I see the words. It says less than 150. All right. Well, less than is pointing to the left, right? And it's not going to have the extra bar on it because it's not a less than or equal to. So I'm going to change this symbol to a less than, which is that one right there. It's pointing to the left. And I've put in 150. I'm going to hit enter. And there we got 0.6835. So P parentheses X less than 150 equals 0.6835. Boom. How are we doing? Seeming okay? Seeming not too bad? Not too terrible? Okay, now look at F for a second. Something should be like, there should be like a little siren going off in your head. F is a little different. It's a between one, right? Now you can spot it's a between one. One, it said the word between, and two, it's got two numbers in it. It's got to be between. Like you can't do that with a standard, right? A standard only has a single number. So when I go to this, I'm going to click the between, and then poof, it pops up with two numbers now. See, I've got this 3, which I'm going to turn into 135, and I got this 6, which I'm going to make 155. And I'm going to hit enter and poof, or click compute, and you get it. So P parentheses 135 is less than or equal to X, which is less than or equal to 155, equals 0.7408. Like that. By the way, the word inclusive there, I sometimes don't even bother writing it because it's the only one we can do. Inclusive means it's got the equal to signs. That's what that means. So don't stress about it. It's I sometimes don't write it because I don't have the space, but it just means that we have the extra. So if you want to write like this is why these are here. That's all. But it's the only one we can do anyway, so I always assume that that is true, right? So we're not gonna play around with not including things. All right, last one. What's the probability that 145 are obese? So that's not a between because it's only got one number. Does it have a direction? Right, it's an equal, right? See, it didn't give you a less than or a greater than. See it? There's no direction, so it's got to be equals. That's what I mean in the sheet when it says given number. Like all you're given is this number. Like you're not given any direction. It's got to be that. It's got to be equal to that, right? So this is giving you a number. So you're going to go back to standard and you're going to change it to an equals and you're going to put in 145. So 145, click compute. There it is. So P parentheses X equals 145, close parentheses, is equal to 0.0428. Poof. Now, we're not done. Read carefully. Reading comprehension. Because we also have to answer, is this unusual, and explain. It is unusual. Yes. Okay. So yes, it's unusual. Why? Right? The probability is less than 0.05. That's on page 253. That's on the first page of the yellow packet, right? Unusual for a probability is being less than 5%, right? You can say 5%, you could say 0.05. They mean the same thing. Don't say under 0.5 though. Careful. It's 0.05. 0.5 is 50%. 0.05 is 5%, right? Got to get that O in there. All right. Are we hopefully feeling slightly better about 6-2? Maybe not perfect, but we're getting there. We're getting there. What I love is this, man. This is so much easier than doing it by hand. I got news for you. Like, oh, these ones, that formula, Steve and I are old school. We didn't have computers. I'm going to sound like your grandmother right now. I didn't have computers when I first did this in college. I had to do the formula that Steve put in the chat, and it was awful. We barely had calculators. We were just shy of like stone tablets, people. Like we're that old. Slates and chalk, that kind of thing. Hey, we first taught on chalkboards actually, so we had chalkboards, right? Yeah, we did walk uphill both ways in the snow, everything. We had to calculate uphill. All right, all right, all right. Yeah. Okay, it was the 1900s. I know, it's true. Okay, all right. So let's go to this one. So this one starts on page 408, so it should be right after. Now, I feel like questions 1A and questions B are very close to what I did in class with you guys last time, right? There's two rules for probability. We covered that already, but there's one thing and then another thing, and they both have to be true, so fill them out. I think letter B, I think I did almost exactly this. So I'm just going to write C 6.1 worksheet 3. It's on the first page of it. I think I did one. It even had cities in it. So remember I said don't use the word countable, right? Countable is not allowed, right? Why is it discrete? I'll tell you one thing, it ties to the cities, right? That's what. Okay. No, well, I want a little bit more, right? So why, how do I put this? You got to talk, just trying to think. Like you got to talk about it in the context here. So talk about it with the little bit of a context about the cities, right? What's going on? All right, then these probabilities. Now this is not binomial. It's good in case this is not obvious to you. The first two pages are 6-1 and the second two pages are 6-2. This is how this is working, right? This is binomial, right? So these are not 6-2. You can't use the StatCrunch here. What you can do is use this graph because it's got the probability of 1 right here. Oh, 0. That's probably 0. Sorry. And then this is the probability of 1. And then this is the probability of 2 and so on, right? So there are the probabilities. So all you're doing is adding them up, right? Or subtracting, right? That kind of thing. So at least 4 means 4 or more, right? That means X is bigger than or equal to 4. Right? So, or less than or equal to, right? That's that symbol for less than or equal to. So you're just going to add up, right? And then does not have 2. That's the 1 minus 1, right? That we learned in chapter 5, right? So these three right here, you're using the probabilities in the graph. And it's just an adding thing, right? You're going to add, you're going to subtract from 1, 1 minus the probability, that kind of stuff. Good. Let's see. F and G, we've done those a lot. G, just a reminder, we go over that on page 128. I'm going to give that a little star. If you struggle with like the difference between classical and empirical, if that's like something you have a hard time remembering, put it on your note sheet. Page 128 in the notes is where it was covered. So that's why I'm giving a little star. You might want to put those definitions on your note sheet so you don't forget. Classical is the from logic one, empirical is the from data one, subjective is the educated guess. Right? Now, the mean, it's saying use the probabilities in the graph, right? Use those probabilities up here. That's what those numbers are for, right? And you're going to be adding, or you'll be subtracting from 1, or you'll be doing that kind of stuff. Is that okay, Cami? Making sense? I'm just going to nudge that. There you go. So I'll leave it up there. But use the probabilities in the graph. I just got lazy. It's probabilities. I didn't want to write the whole word. All right, next, H. Now, H always gives people issues. because it's hard to remember what to do. You notice that it wants the mean and standard deviation. Okay. So we have on the second page of our yellow packet how to find the mean and standard deviation for different situations. This is not a data in a single column action, right? It's a discrete probability distribution. You know how I know? Because you are going to write why it is that for letters A and B. A is why it's a probability distribution. B is why it's a discrete. So it's a discrete probability distribution. So you're going to follow these instructions. You're going to enter your X values in a column. Okay, so just a little side note. What are the X values here? If you were going to enter the X values, what are you entering? The cities, right? So you'll go 0, 1, 2, 3, right? See it here. I can make a little table over here, right? So these are the X's, 0, 1, 2, right? Stuff like that. Then it said, and the probabilities in another column, right? Well, the probabilities are right here. So this is 0.34. This is 0.26. This is 0.24, and so on. These are the probabilities, right? So you're going to make a table like that, and you're going to go type it into StatCrunch your own self. See? See how this works? Here, I'll just leave that there for a second so everybody can write it. So that's what you're going to do. So you're going to turn that graph into a table, right? Because a graph is just a table written with bars, right? But there's your X's right there. There's your probabilities right there, right? So you're going to go put them in to a table. People got it? Can I move the paper? We're okay? So I got to shove back down to the bottom here. So, yeah. Oops, people still writing. Okay. So I think I see a lot of thumbs. So now, once you do that, then you go to Stat Calculators Custom. Your X values, which is your cities, go in one, and then your prob, right? So here's what I'm going to say. Page 254, number 3. It's the Stat Calculators Custom thing, right? You got to do that to find these two. What are the symbols? Since this is a probability distribution, what are the symbols for the mean? Sorry, the symbol for the mean. It's not plural. Mu, that's right. We talked about this in the notes. It's a population. Probability distributions are essentially all potential futures. It's the whole of the future. And therefore, it is a population. So it's mu and it's sigma. Have to do some problems by hand. Oh, that's a good question, Cora. So, am I going to have problems on the exam where you have to do things by hand? I think you mean mean and standard deviation by hand. Um, you always have the StatCrunch option to do the mean and standard deviation, right? I mean, we do some things by hand, like, I mean, by hand is a weird term in this course because we write the formulas by hand and then we do Desmos or we use StatCrunch. Like, so by hand, we don't do a lot of, if that makes sense. But I think what you mean is the mean. Am I going to make you add them all up and divide by how many there are? No, right? You will use StatCrunch or there is a one case, the gambling one on this page. This gambling one you could do by hand. Actually, it's a little easier than doing it with StatCrunch, but you could do it either way. Did that answer that question? Hopefully it did. Cool. All right. So then interpret. Okay. We all know how to interpret the mean and standard deviation, hopefully at this point. That's the give or take script, the regular one, not the special one for 6.2. So it's the give or take script on page 253, and that's all I'm going to say about it. Right? We've been doing that a lot. So hopefully everybody's getting used to it. But good question, Cora. I'm trying to rack my brains to think of if there's like a by hand thing that's like for sure by hand. Even when we say by hand, what we really mean is show the work, like show the formula, like z-scores. Like you do the z-score by hand, but you're really just showing the formula and then you make Desmos do it, right? Yeah, the rated grade question. That's kind of a personal choice. You could always do Stat Calculators Custom for those, or you could do it by hand. Wait, you know what? Wait till the gambling one. Wait till Baccarat, and we'll talk about it. All right, so everybody thumbs up when you wrote it all. I'll just wait. I will take a drink while I wait. Since I'm doing a lot of talking. Okay. So the weighted grade one is kind of the same as the Baccarat one in a way. So, but this one, I don't really have much to say because this is the same thing we just did. So, um, find the mean and standard deviation and give their symbols. It's the same thing. It's just more practice. Mean is this, standard deviation is this. Fine. So that's page 254, number 3. Again, you would use StatCrunch. So this is kind of getting to your question. You could do this by hand if you wanted to. It's not that hard. You just multiply this times this, this times this times this, then you add them up. So like, I mean, sure, but no, I mean, when they get that long, everybody just kind of uses StatCrunch, right? But you could do it by hand if you wanted to, but it's not required either way for that one. What I will tell you is required. We saw it on the cumulative review. Remember the first page of the cumulative review we did last time where it had like a data set and a column and you guys had to like find the mean, find the median, find the mode, find the Q1, find the Q3, find the IQR, that stuff. That you do with StatCrunch. You do not do that by hand. So that one I demand that you use StatCrunch. Same thing with regression. You're not doing that by hand. You're doing regression with StatCrunch, right? Stuff like that. So, but these weighted mean ones, it's kind of a personal choice. And then interpreting the mean and standard deviation, again, that's the script on page 253. We all know the same thing. It's the give or take script. Okay, so that's just more of the same. Let's talk about Baccarat, because Baccarat is a weird game, and I like it because I love it because it gives me questions to ask. Okay, so in Baccarat, you're essentially there's things going on. So there's a player and a dealer, and they're choosing a card. And you, as the bettor, can bet on different outcomes. So you can bet that the player's card is going to be higher than the dealer. So you can say, like, they're pulling. So pretend I'm the dealer and Steve is playing with me, and you guys are all watching, right? So what's happening is I could pull the higher card, he could pull the higher card, or we could tie, like we both get a queen or something like that. Okay. As a bystander, you have a choice on who you're going to bet on. Do you think he's going to get the higher card, which is the player is the higher card? Do you think I'm going to get the higher card, which what's that outcome? Let's see if you see it. Dealer higher. That's exactly what it is. So you're betting on the player, you're betting on the dealer, or you actually have a third option in Baccarat. You can bet that they're going to tie. Right? So what's happening is we are betting on a tie. This particular setup, now there is another one of these in your sample midterm where you're betting on somebody else. I can't remember if you're betting on the dealer or the player. But anyway, so this problem changes depending on who you're betting on. We are betting on a tie. So we will only get money back from the casino if it's ties. If the player, like you're just watching, the two of us are playing and you're betting that we're going to tie. That's how you're going to get money out of the casino is if we tie. If I'm higher, if the dealer's higher, you lose. If he's higher, you lose, right? You being the third party watching this. Everybody see how Baccarat works? It's a little weird, right? It's kind of fun. Okay, so if the player has the higher card, if Steve, he's right over there, you can see my arm in his shot, right? He's right there, right? So if he has the higher card, what do you get? What's your profit? Steve has the higher card. There we go. No, that's your winnings is 0. What's your profit? They don't let you get money for nothing in a casino. Money, please. Yes, yes, -1. You lose, right? If he gets the higher card, you lost because you were betting on a tie, right? It's right here. If the player's higher, -1. If the dealer's higher, if I have the higher card, right? Then it's -1, right? Yeah, you're betting $1. That's why these are negative here, right? Normally, when a casino writes this, by the way, casinos don't put the negatives in. I did that because I think it gets a little confusing. Casinos, when they write this, they write 1:1:8, right? but it's you lose $1, you lose $1, you gain $8. So your profit if you win is 8. The way these are written always is your loss and your win. Like it's always that. It's a ratio of loss to win. Normally they don't bother writing the negative with them, but I did it just to help you guys out. Right? So it's -1 for this one, -1 for this one, and 8 for this one. Right? Because all you can lose in a game is your ante. If you're betting $1, then that's all you can lose. You can't lose 2 because you only bet the $1, right? So you can lose your dollar this way, you could lose your dollar this way, or you could win the $8. Is that making sense? It's a little weird, I know, but just remember that it's all set up for you. -1 here, -1 here, +8 here. Poof. And the one in the sample midterm works very similarly. So prepare yourself, right? It's not the same, but it's very similar. Okay, now we are missing one of these probabilities right here. There's a hole in our table. How do we find it? Right. You know the probabilities have to add up to 1 because we all remember that from chapter 5, right? So you got to add these two up and take them away from 1. Or just take them away from 1, right? You got to take these two puppies away from 1 and you're going to get what's missing. Oh, it looks like JB already did it for us. Thanks. It's 0.095156, right? If you want to write yourself a little note, it's 1 minus these two, right? So you add those two up, right? And then you take them away from 1. Is that making sense, everybody? Add them up, take them away from 1. Add them up, take them away from 1. Okay. Now, if we're good with that much, the expected profit should not be bad. That's the mean. Oh, I will tell you, answer your question from earlier. We never learned how to find the standard deviation for something like this by hand. You'll notice it's not asking for standard deviation. If it asks you for standard deviation like this one, you have to use StatCrunch because you don't know how to find the standard deviation by hand for a table like this. It's more complicated than you might think. So this one, though, all this one wants is the mean. Well, means are kind of not that bad to find, right? So you have a choice. You could do it by hand, or you could use StatCrunch. By hand is not that bad. What you do is you take the profit, -1, and you multiply by the probability, 0.446247, minus another one times its probability, 0.458597, plus 8 times 0.095156. Boop. You'll have it. So either do that or use Stat Calculator's custom. It's personal choice. So you do whatever makes you happy to find the answer. Right? So if you want to do it by hand, fine. It's not that bad. You just take the profit times the probability, profit times the probability, profit times the probability, and you add them up. Right? Or you can do type this guy in StatCrunch, type this guy in StatCrunch, and then do the custom calculator thing. Whatever makes you happy. Students usually like one way or the other. They just, makes them happy to do it one of the ways. So it's fine. Now, it does ask for units on this. So what would be the unit for a gambling game like this? Money. Yeah, dollars. Yeah. And also, what for the record, this is a casino game. So just think about this. This is a casino game. So not only will it be dollars, but it better be what? Your expected profit. negative. Mhm. Negative. You as a player are going to lose money if you stay and spend time at casinos, if you gamble in any way, quite frankly, right? So it's going to be a negative dollar sign. It's just a question of what is it, and that you guys can find. Okay, so then how do you find out your high roller money? So if you have a high roller that bets 500 instead of a dollar, how does it change? And the answer is it doesn't. What happens is you take the thing you got for the dollar, you take this number right here for letter B, and you multiply it by 500. And that's it, right? So I'm just going to write that. It's 500 times your answer for B, right? Whatever your answer is for B, you just multiply by 500, you got it. It'll be negative dollars again, I can tell you that. Okay, next. I just said it, but I'm going to say it again. When you are at a casino, you're going to lose because every game in a casino has a negative expected profit for the player. Every single game. That means that the house has something called an edge. That's what the house edge is. And it's positive, right? Because it's positive for the house. Exactly. So whatever this number is, it's positive that number for the house, right? And they always write it as a percent because they always want to think of it as basically a portion of the money, right? So this number comes down here and you make it positive and you make it a percent and you're done, right? Because what the player is losing, the house is winning. The house has that edge on the player, right? In the long run, the house is making money and the player's losing money. That's why they want to keep you in the casinos. That's why they give you free alcohol and shows and things like that, because they want to keep you there so that you will lose more money. Or if you're up, they want you to be down. Right? Okay. I'm just going to give you guys an example of this real quick. Suppose the answer for B, example, if the player up here was like negative 0.056, then down here the edge would be 5.6%. You make it positive and turn it into a percent, right? That's how that works, right? So you take the player's loss, make it positive for the house because the house is gaining it, and then turn it into a percentage because that's just how they roll, right? They want to think of it as the percentage of the bets. All right. And then as for why Baccarat is not a fair game, um, no game in a casino is. All right, so no game in a casino is a fair game. So why is that? You don't want to get into the argument about the cards, right? About the probabilities, right? You don't want to be like, oh, the chances of it's not about the chances at all. That's not what makes things a fair game, right? Fair game is not about the probabilities. Fair game is about the money, right? So you should be making a money argument here, right? And we made that argument in the notes on page 155. We also did it in the 6.1 worksheet, right? So we've also seen it there, right? What it takes to make a fair game. So I'm just going to leave that with you. So that's the hardest question on this thing is that Baccarat one. But it won't be too bad once now that we got this set up here and you guys know how to do that, the rest of it's not. C, D, and E are not hard, right? If you know what you're doing, right? They don't take much, right? You just pop them in. But getting this set up right and getting this B right, that's the hard part of that question. So, all right, everybody thumbs up when you got it. How am I lagging tonight, by the way? Am I lagging again like I was the other night? It's all good? Good. Good. Yay. Oh, my dog moved. She'd been underneath my feet this whole time and I couldn't put my legs out. And now she's finally gone. Yay. Okay. I so don't need to talk about this one because we just did it. Right. We did it with the spinner. It's the same thing. These next two sheets are 6-2. See how this works? So the first two sheets are 6-1. This is 6-2. This is all binomial. So I'm just going to say See page 406, which was the 6.2 worksheet number 3. I will give you a hint. There's one of each. Right? There's one of each kind here. So there you go. Moving on. So there's that one. This one is really easy because we just make StatCrunch do this. This is all in stat, calculators, binomial, right? Use StatCrunch to do this. You are not allowed to do by hand formulas. You don't know how anyway, so don't do it. Right, use your StatCrunch. Pop them into the computer. Good. This one, we did in the notes. This isn't particularly tricky, but do you remember what we did in the notes? So you've got these are binomial, and you know that n is 260 right here, and you know it's binomial. So the center of your graph is your mean. And the mean for a binomial is n times p, right? So n times p. So what you do is you take your n and you times it by p, and you take your n and you times it by p, and you figure out like which one of these has the center where you want it, right? Because the centers are down here, right? So which one's going to be where you want it to be? Ta-da! And you just write it down. It should not take you very long. I did an example in the notes on page 163. It's the very, very last page of 6.2. So good there. Thumbs up, we're good. Troubles, ready for me to flip? I'll just wait. Is that a Lego Ghostbusters behind your head, Aaron? We have that one. It's in our basement. The Ghostbusters car. Sorry, I just saw Legos over her head. Sorry, guys, got distracted. I have a Lego Baby Yoda. Here. Lego Baby Yoda. Here he is. That's my latest one. I have others. There are more Legos up here. All right, sorry. I stopped. Sorry, I'm stopping. I'm not going down my Lego path here. All right. All right, next. I just did one like this too, right? Didn't we just do we did one with obesity, right? So this one is not about obesity, but let's double check a couple things. When we want to do P, the probability of success, what is it? Yes, it's right here. That's your P. And then you're going to write it as a decimal. Do not write it as a percent. Percents are how we write a paragraph of English like this. It's not how we write the math, right? So we're going to switch this to a decimal. Decimal. And we just did ones like this, so I'm not going to explain most of this, but success should be 2 words, and that's it. Don't write more than you need. So in this case, what is success? Bullied online, right? Not the teens part. The teens is the group you're pulling from, right? But it's bullied online, right? So this right here, that's success. So bullied online, period. And therefore, I think you guys can figure out what failure is. We'll leave it at that. Now, X is the hardest part. So X is the number of successes. So it's the number of, how about this? Number bullied online, right? That's the number of successes out of this many. And then the group is where this comes in. It was this many US teens. That's where the teens comes in, right? And then this will be your N when you put your N in. And then this, remember we have a formula for this. This is N times P, and this one is the square root of N times P times Q. Those formulas are all on page 256. Everything is on page 256 that you could possibly need for this page. It's all there. So the hardest part usually for people is S and X. Like just trimming down S, success, so that you're only saying the bare minimum, right? Bullied online. That's what you're talking about. And then the teens part comes into this part, the X part. It's not, think about success this way. It's not who it is, It's what was done, right? Or what's done to them. They're obese, right? It's not who they are, it's that they're obese. It's not who they are, it's that they're bullied online, right? It's what thing is true about them. It's not who the people are, it's what is true about them, what you're looking for. All right, I got to nudge the paper a little bit just to get down here because we just did ones like this. We just did one. So I'm going to let you guys do all this, but I will remind you that down here, you're going to do stat, calculators, binomial, right? The probabilities on this page should not take you very long at all, right? D, E, F, G, they're not bad, right? D, E, F, and G are quick because you're going to make StatCrunch do it. What's hard is just writing out the script for the give or take and then like what this thing means, that kind of stuff. That's what takes a little bit. Don't forget on letter G to answer if it's unusual. Don't forget that one. It's easy to miss on that question. All right, feeling good? Feeling like we get it? Ready to get to it? Woohoo. All right, so I'm going to pause the recording. Bye, recording. Let's see. You guys had a ton of good questions tonight. It was a good job.